Welcome back to this YouTube channel. My name is Anubhav, and today I'm going to be talking about workload security using next generation firewall ASA in public cloud. I will be covering Amazon Web Services and Microsoft Azure. I work on different kind of deployments where we use next generation firewall and ASA to protect workloads in public cloud. So here is our agenda for today. This video is going to be a long video, so sit back and relax. I'm going to be starting with introduction, where I'll talk about different kind of services in cloud, why our customers are moving into public cloud, and how can we provide them threat-centric security solution for their cloud environment. I'll talk about Cisco Security Toolkit. We have different components using which you can provide security to your workloads in the cloud, and then I will deep dive into workload security in Amazon and Azure, where I'll talk about use cases, scalable models, because scalable model is really important to understand, because when you move your workload into cloud, you may be deploying your workload with load balancer so that your workload can scale whenever required. So I have something on the same topic where you can scale your network firewalls as well, where you can have a load balancer sandwich design. So I'll talk about scalable design in detail, and in the end I will be talking about licensing, because it is important to understand licensing, how exactly these components are licensed in the cloud. I do have few resource links which will help you understanding our complete security solution for public cloud. So I'm going to start off with old days, where we had all our applications in the data center. The advantage of this model was you had full access of all the applications, full visibility. Even if you had a virtual environment, everything was under your control. So you had full visibility and full control over the traffic and who can access what. That is really important, because the moment you go to cloud, you lose this visibility. Now, if you look at the current trend is applications are moving outside of your data center, maybe in form of infrastructure as a service, platform as a service, or software as a service. So your workloads and your applications are moving outside the data center. Why these applications are moving outside? Because in the public cloud, you get a lot of benefits. Like it is really easy for you to bring up new applications. So there is application agility. You can bring up your new server with few click of mouse, and you can enable your service in a couple of minutes. In the cloud, you also get advantage of having HA. Now, HA is really important to understand, because HA can be a local device HA, or it can be a geographical redundancy as well. All the cloud providers, they provide you different kind of regions and availability zones. You can plan your solution in such a way that your applications are distributed based on the different geographies, right? So that kind of possibility is really available in the cloud. Scalability is another thing, really important thing that is there in the cloud, because you will find features like auto scale set and auto scale groups, which will let you scale your application horizontally. If there is a lot of traffic hitting on that application, you can scale it horizontally. Low cost, if you're moving your significant workload in the cloud, you will be billed based on hours. They have introduced per minute billing as well, and now they have came down to per second billing as well. Now, I can see that we have a lot of our customers who are now evaluating public cloud. Few customers are already in the cloud, and they're trying to create a hybrid security model. When I say hybrid security model, they're trying to connect their data center with cloud environments so that there is proper communication between the two different environments. And we also have customers who are already in hybrid cloud. Now they are going multi-cloud. So things like that are pretty common nowadays, and applications can move anywhere. Challenge of this particular model is visibility and control. The moment you move your application outside of your data center, you lose control of that application and you don't have visibility of what is happening in the network. But with appliances, virtual appliances like ASA, next generation firewall, you still have option of protecting your workload in the cloud the same way you protect your workload in your data center. So I'll talk about that in detail in the upcoming slides, but let's go and talk about layer 2 abstraction. So when you move to public cloud, there is layer 2 abstraction. You don't have layer 2 functionality available for customers on the cloud. That means that you don't have features like clustering, HA, native HA in the cloud. In order to achieve HA, you have different models. You can use your API calls, or you can use a load balancer sandwich. I'll talk about that in a bit. Security model is another important item. So when you go to public cloud, you are still responsible for your workloads and your data. Cloud provider will provide you physical layer security, virtualization layer security, but in the end, as a customer, you are still responsible for your data. So you will have to deploy your security solutions in the cloud. When you go to cloud, there are hundreds of services available. I'll talk about those kind of services, and it is really important that your security solutions should be easily integrated with cloud services as well. Now, these are a few options or advantages why customers are going to cloud. 24/7 support, agility, utility-based model, highly automated. You can create your ARM templates, CloudFormation templates. You can automate your workload deployment. Not only workload deployment, you can automate entire virtual private cloud or entire network deployment using these kind of templates. Devices and location independent, so you can deploy your services anywhere across the globe, in any region, in any availability zone. So this is why customers are pretty excited about public cloud, and they're moving to public cloud. Now let's talk about public cloud services. Now, I understand that you might have a good understanding of all the services, but I'm going to give you very high level information about different services in Amazon and Azure. Amazon has a lot of regions across the globe. Inside a region, you can create your virtual private cloud or VPC, which is your isolated environment, and you will have control over all the resources that you deploy inside your virtual private cloud. Inside a region, you will definitely see that there are multiple availability zones. Consider these availability zones as your as a fault tolerance zone, or two separate data centers which are connected to each other using a high speed link, and with redundant power, redundant cooling, and redundant network. So you will see that your applications can be deployed in multiple data centers, and if one data center is down or availability zone is down, your applications are still reachable from another data center or another availability zone. Inside your availability zones, you will create your subnets. Then you will deploy your workload known as EC2 instances in Amazon. You can access your EC2 instances using private IP address if you have Bastion machine or a jump host in your cloud environment. Or if you have direct connect going to your data center, you can use private IP address as well. Imagine you don't have those kind of functionalities, then you can map a public IP address to your workload, and that mapped IP is known as elastic IP or a public IP, which can be used for accessing these workloads directly from internet. Then there is a load balancer. Load balancer has different models available based on your requirement. You can pick and choose. So they have network load balancer, classical load balancer, and application load balancer. I'll talk about each load balancer in a bit when I'll talk about scalable design. Now, there's something known as IGW or Internet Gateway. If you require internet connection in your virtual private cloud, first thing that you will do is you will create your Internet Gateway. Then you will create a route table. Based on your route table, your traffic is routed. So if you look at this route table, I have added a default route which points to my internet gateway. I'm doing this because I need to provide internet connectivity. Till this point, nobody will get internet connectivity until and unless I go ahead and associate this route table to a subnet. For example, if I need internet connectivity in my outside subnet, I can associate route table RT to my outside subnet, and that will provide internet connectivity. There is another component known as virtual private gateway, which is for VPN functionality. You can use it for doing a VPC peering. You might have multiple VPCs and you want to use VPC peering feature, which will connect your VPCs. You can use your VGW for that, or you can connect back to your data center using VGW as well. Another form of connection from your data center to your cloud environment is direct connect. Generally, it is a high-speed link where you will have your co-location facility involved. They'll provide you high-speed link going down to your cloud provider. So when you deploy direct connect, you would be using virtual gateway as well. Now let's talk about these services in Azure as well. In Azure, whenever you create any resource, that resource is deployed in a resource group. They also have regions and availability zones similar to AWS. Multiple regions and multiple availability zones are available. First thing that you will do is you will deploy your virtual network. Virtual network is similar to virtual private cloud. You will have full control over all the resources that you will deploy here, and it is your isolated environment. Then you will create your subnets. Inside your subnets, you will deploy your workloads. You will control your traffic using user-defined routes or UDR. In UDR, you can specify your next hop and you can point it to a VM, you can point it to local VNet, you can point it to a lot of other options are available. When I will talk about UDR in detail, I'll talk about UDR. But UDR can be created, it can be associated to a subnet, and your traffic is routed based on UDR. Now, in terms of firewall, you have next generation firewall available there. ASAv is also available there, and these appliances are known as network virtual appliances or NVAs. You can create your availability set as well. Now, it is really important to understand what is availability set. Now, availability set is an attribute that is added to your workload. So if you want to place multiple firewalls behind a load balancer, it is required that your workloads are in an availability set, and make sure that all workloads are in the same availability set. What this availability set does is it will make sure that your workload is deployed on a separate piece of hardware on Azure environment. So if there is any kind of hardware failure in Azure, or if they are running any kind of software maintenance, since you have your workloads in an availability set, all your workloads are deployed on separate hardware and your services are not impacted. They have internal and external load balancer. Internal load balancer can load balance traffic internally within the VNet, and the external load balancer can get traffic from outside because it has a public front-end IP address. So users from internet can put their request on the front-end IP, and then front-end IP is going to get that traffic and load balancer is going to load balance it. There is something known as express route as well, similar to direct connect. In order to build this, you need virtual network gateway as well. This virtual network gateway is deployed in gateway subnet. So what you need to do is you need to have a direct connection or express route connection going from your Azure cloud to your data center. Generally, you will see a lot of different options in terms of speed available for express route. The latest one that I saw was the 100 gig Azure Express route. You can look at the Azure page and get more information about different kind of options available for Express route. Now, this is what we have discussed till this point, but this session is going to be on security. So we'll be focusing on security. So I just gave you information because I wanted you to understand different kind of services, because throughout the presentation or throughout this video, I would be referring to these options one by one. So let's focus on security. For providing you security, these cloud providers will give you security group, network ACL, or network security group. Azure also has a layer 7 firewall. I will talk about that in a bit. And so this is what you have in the cloud if you want to secure your infrastructure as a service environment. If you are moving your workloads into cloud, you can definitely consume your firewalls and ASAs in the cloud and provide same kind of security and advantages. You can use your existing management tool to manage those devices as well. Now, why are we here? It is really important to understand we are not here to discuss about different services of cloud. That can be learned from a cloud infrastructure session also. We are here to understand if there is a security hole in our network that is the end for our enterprise. No matter how many security devices you apply, if your security policies are not consistent, if you are not deploying right kind of security in your cloud environment as well, your data can be stolen anytime. So let's talk about different types of security devices and different features that we provide in cloud. Let's begin our journey towards secure cloud environment. Now let's focus on Cisco Security Toolkit for public cloud. It is really important to understand what we offer, and then we will build on how to put those appliances in cloud and different kind of use cases. So now you may see different kind of services in cloud. If I talk about firewalls, we have virtual, next generation firewall, management center, which is firepower management center virtual. ASA is a pretty strong use case for VPN, site-to-site VPN, and remote access VPN. We also have umbrella connector. I'll talk about umbrella connector in a bit, but just to give you some idea, umbrella connector can provide you first level of defense by looking at your DNS queries and stopping you from going to the bad infrastructure. You will see tetration for cloud. You will see Stealth Watch for cloud. I'll talk about Stealth Watch for cloud at a very high level in this video, but you will see different kind of devices there. But focus of this session is going to be next generation firewall and ASA. So let's talk about next generation firewall, what next generation firewall is, and what kind of features you get when you deploy next generation firewall. So next generation firewall is a firewall that will give you stateful firewall functionality, NAT, route, static routing, dynamic routing, and apart from that, you have application visibility and control. You can create your rules based on application. You can say somebody or anybody in the network cannot access Facebook, right? Those kind of things. You get the application visibility, and based on that you can create your rules. Then we have feature, which is an optional feature. You can enable it by adding a license subscription to it. That is next generation IPS. So next generation IPS can be enabled. Then we have advanced malware and protection for any kind of malware going in your network. And we have URL filtering as well. So on this virtual appliance you can enable URL filtering. Also, the other or the biggest use case is VPN for cloud, because you will definitely have remote access users who will be terminating their AnyConnect VPN on this device. So AnyConnect VPN is supported on next generation firewall. Then we have security intelligence. So we get all our intelligence from Talos. So any kind of threat that is detected across the globe is updated in Talos, and same kind of intelligence can be brought down to your virtual appliance level as well. Now, this virtual appliance is available in different form factors. The first one is the hardware appliance. You can purchase Firepower 1000 series, 2100, 4100, 9300, those kind of physical appliances. You can deploy virtual appliances on a VMware ESXi environment. You can deploy it on KVM. You can deploy it in public cloud in Amazon Web Services and Azure as well. Now let's discuss about management option. You have multiple management option for this appliance. Currently, we can manage it using Firepower Management Center, which is a centralized manager for managing multiple next generation firewalls. You can find FMC in hardware appliance form factor as well. You can deploy it on a virtual machine running ESXi or KVM. You can also deploy FMC in cloud. If you don't have any data center and you only have cloud presence, we also have FMC available in Amazon Web Services and Azure. The best part of this particular solution is you have a pretty solid or pretty good dashboard from where you can get more information about what is happening in your network, and most of the things are API driven. You can write your API Python script and use APIs, and you can orchestrate your deployment of the policies, deployment or initialization of the interfaces, those kind of things, pretty flexible. On the physical appliances, we have Firepower Device Manager, which is a local device manager of the box, currently not available in public cloud, but this is definitely a good software if you are using physical appliances. Now, this is what I was talking about, API or Firepower Management Center API. So we have a built-in tool which is known as API Explorer. If you want to orchestrate anything, you can go back to that tool, and this slide will give you more information on what you can orchestrate today. Maybe this sheet is outdated. You can find latest information on our API page. You can go there, look for all the object, go to API Explorer. On the left hand side, you will see all the options like deployment, device group. You'll get updated information there, and based on the version that you're running, these options will change, because in every release we are adding new API capabilities, because we know that industry is moving towards automation and orchestration. So this is really important. If you have a DevOps team, they can always use these kind of tools and provide automation and orchestration. This for management access, you can place this device at the edge in your cloud environment. If you want to manage it directly from internet, you can map an elastic IP address or a public IP address to it, and you can manage through internet. If you have jump box or bastion machine, you can use that as well. And the other thing is, if you have express route or direct connect going to your data center, you can use that route as well. But you need to ensure that you have HTTP connection to your Firepower Management Center, and we use port for secured connection between your Firepower or your next generation firewall and your Firepower Management Center, and that port is 8305, which is used for SF tunnel. So you need to ensure that there is a proper connectivity, proper traffic rules are allowed so that FMC can form a SF tunnel to your device. Now, ASA is another thing that is available. So today we have ASA 9.12 available in the cloud. You can deploy it on VMware, you can deploy it on Hyper-V, KVM, AWS, Azure, and then we have it available on physical appliances as well. So this ASA software is widely deployed, and I will not spend much time on explaining what ASA is, but it is a pretty strong firewall at the edge for VPN and IPsec or SSL VPN, remote access VPN, or site-to-site VPN, definitely there is a big use case for route-based VPN as well, because few cloud providers prefer route-based VPN over policy-based VPN. So we do have that option as well. On the management side, we have ASDM, which is a local device manager for this device. If you are into GUI, you can always access ASDM. We also have CDO, which is Cisco Defense Orchestrator. Using Cisco Defense Orchestrator, first of all, CDO is our cloud offering. Okay, so you can always use CDO to manage your ASA. You can manage your next generation firewall as well. And on the ASA, you have pretty strong CLI. So if you are into writing your commands, you want to use CLI, you can always go back and use your CLI as well. For centralized management, there is a pretty strong tool which is known as Cisco Security Manager. It can manage multiple devices, and advantage of using this particular tool is you can create policy once and then you can apply it on the multiple firewalls as well. Apart from this, pretty strong API support is also available there. You can orchestrate your configuration using API. You can use APIs even for monitoring as well. Again, management of this device, again, you can use, you can map elastic IP address or public IP address and use the internet route to access it. If you have jump box, you can use jump box as well. If there is a direct connect, you can use direct connect or express route as well if you want to use private IP address. Only difference is on the ASA, we allow you to make any interface as your management interface. So if you want to use inside interface as your management interface, you can enable management on that interface and you can manage your device directly from there. Now, umbrella connector is really important to understand. What is the use case for umbrella connector? It provides you visibility and security enforcement at the DNS layer. So imagine if you're going to a website that is known for a malicious traffic. So you can send a DNS query, and ASA can intercept that DNS request, and it will rewrite DNS address to the address of the DNS resolvers available on the internet, and it can provide you detailed information. It can give you, it can basically block you from going to that particular site. So there is a secured communication happening between your ASA and your umbrella account. You need API keys and customer tokens, so it is pretty secure. You can enable that connector on your ASA. Now let's look at the traffic flow. Imagine you have a workload sitting in your AWS environment or Azure environment, and you have ASA at the edge, which is connected to internet. Now when your workload is going to send a DNS query, that DNS query is intercepted by ASA, and ASA is going to initiate eDNS, which is an encrypted DNS request, and this request will go to DNS resolvers on our umbrella cloud, and umbrella is a cloud offering, so it'll go there, and based on your query, your umbrella resolver is going to send a response back. Now when you get your response back on the workload, two things will happen. If your site is a malicious site or a policy says that you should not visit that site, you will be presented with the server block page. Or if your traffic should be allowed, you are forwarded to the website. Pretty strong tool. So it works at the DNS layer, so anything which is going to a malicious domain or trying to go to a command and control center, that kind of communication can be blocked at the DNS layer itself. StealthWatch, again, I'm not going to talk in detail about StealthWatch, but StealthWatch is a pretty powerful tool that can give you complete visibility of what is happening in your network. So in your data center, you can send your net flows to your virtual appliance, StealthWatch virtual appliance, or in the cloud as well. It is the SaaS portal is available. Software as a service portal is also available. You can send your AWS or Azure traffic to StealthWatch appliance for giving you visibility. Now, if you look at this particular example, I have added this example. You can deploy StealthWatch in your cloud pretty quickly. Under 10 minutes, you would be able to get all the visibility that you need, because it gets the information directly from VPC flow logs. You can integrate it with CloudTrail, CloudWatch, Lambda. Those kind of things are available, and there's a proper documentation available on our website how to integrate StealthWatch for cloud. In Azure, you can definitely go with native flow logs, and there are other options available which were recently introduced in the StealthWatch for Cloud. So kindly go back to StealthWatch for Cloud and get more information on what StealthWatch for Cloud is, how this solution can help you get more visibility. Now let's talk about different firewall instances that we have. So we have next generation firewall available in Amazon Web Services. We have C3, C4 instances. For management, we also have 2XL instance. So if you want to manage multiple firewalls, we suggest you to go with a bigger instance. And recently in 6.4 release, we have added support for FMC in Azure as well. For FMC in Azure, we have standard D3 and D3 v2 instance, so we cover almost all the regions across the globe. If you go to marketplace and search for next generation firewall or FMC, you will definitely find it in all the regions. Now on the ASA side, we currently support C3, C4 and M4 instances, and if you're deploying a large instance, it is ASA v10. If you're deploying an extra large instance, it is ASA v30. Now if you go to ASA v instance in Azure, you will see standard D3 and D3 v2 instance. Now if you deploy ASA in Azure environment, you will deploy ASA v30, but we give you option of entitling it for ASA v5, v10 and v30. You can refer to a data sheet about what is the difference between ASA v5, v10 and v30. Generally it is throughput and number of VPN supported. For example, on ASA v5 we have 50 VPN endpoints. On ASA v10 we have 250 VPN endpoints, and on ASA v30 we have 750 VPN endpoints. So you can always go back to our data sheet and get more information about different models, but intention of this slide is to tell you that we have pretty good presence in all the regions, not only in the public cloud, but we also have availability in Gov Cloud as well. Now let's see what is new. So I mentioned that in 6.4 release we have added Firepower Management Center. This image is available in Marketplace. You can deploy 6.4 FMC. You can manage up to 25 firewalls. You can manage your on-premise devices from this. If you have multiple branches, you can manage those devices, and you can also manage your firewalls which are natively deployed in the cloud. Again, a D3 v2 and D4 v2 instances, I have specified different kind of space required or instances available today, and you need to have your 8305 port available or opened in your NSG, because that is the port that is going to be used for secure connection between management center and your firewall. So that is something which you can look inside your security groups or network security groups. This is not related to public cloud, but I've added this information here to give you more information about our virtual FTDV or next generation V for the private cloud side. When you deploy it on KVM or ESXi, you can see that we have deployed, we now have an offering where you can increase your vCPUs from 4 vCPU to 8 or 12 vCPUs. Based on your requirement, you can adjust your CPU, and then accordingly memory is going to be selected, and throughput is dependent on number of vCPUs that you pick. So this model is today available for ESXi and KVM only. In order to go ahead and increase throughput, you just need to shut down your FTDV and then add more vCPU and switch it back on. Okay, so it is really simple. If you need more throughput, switch it off, add more vCPUs, switch it back on. Deployment models, we can deploy firewalls in routed mode, passive mode, in the cloud, and it's pretty simple. You can put it at the edge for VPN functionality. You can put it between two subnets for inter-subnet filtering. You can deploy next generation firewall in passive mode as well, that uses ER-span. If you have any device like CSR in your network which is capable of doing ER-span, you can create a passive interface on next generation firewall with an IP address, and you can receive ER-span on that interface. In Azure environment, we support routed mode today because there is no support for ER-span in Azure. So that is something we are looking at, and we are trying to figure out how exactly we provide passive mode in Azure. But pretty flexible, routed mode or passive mode, and based on your requirement you can deploy this virtual appliance. Now let's look at VPN. So VPN is something which is a pretty strong use case. Now if you look at this particular example, I have firewalls at the edge, and requirement is to have multiple firewalls. In this example I'm just using two firewalls. You can have multiple firewalls as well. So my remote access users will terminate VPN on firewall 1 because that is going to be their primary VPN peer, and on firewall 1 I'm going to have a separate VPN pool, and for firewall 2 I'm going to have another VPN pool, and based on my VPN pool I will be having my routes in the route table. So if anybody connecting to VPN pool 1 or firewall 1, return traffic will go back to firewall 1. In case firewall 1 is not reachable, I will initiate a connection to firewall 2, and since firewall 2 will get different VPN pool, traffic will always come back to that firewall. And how I manage this kind of VPN switchover is based on my VPN profile. There is a tool available, VPN profile creator. Using that profile creator, you can specify multiple VPN peers, and if your primary VPN peer is not available, you will make connection to your secondary VPN peer. Site-to-site VPN tunnel, similar kind of setup. In your site-to-site VPN tunnel, you will define multiple peers, and if your primary peer is not available, you will connect back to secondary peers. That's it. So this is how you will form your VPN connection for remote access VPN, and even for site-to-site VPN connection as well. The other use case is going to be your inter-VPC connection. There may be a situation where you will have multiple VPCs or VNets, and you want to connect those networks, and if you have overlapping networks, your VPN peering or VNet peering will not help you because there is no NAT functionality on it. There you can deploy firewalls, and based on that, based on your NAT translation on the firewall, you can always create a VPN tunnel, site-to-site tunnel between two VPCs, two or more VPCs, and then you can bring up your entire setup. So if you look at this example, I have VPC-A talking to VPC-B and VPC-B talking to VPC-C, and everything is happening through a site-to-site IPsec VPN tunnel. And I might have overlapping network that I can translate on both firewalls. Pretty simple. So if you run into a situation where you have overlapping network, you can always go ahead and deploy these firewalls, ASA or next generation firewall. Now let's talk about native components that we use when we deploy these devices. First one is UDR. I talked about UDR. It is user defined route table. It is a route table that you can create. You can forward traffic based on the routes given in the route table. It overrides your system routes, and you can associate this route table to a subnet. Now in the next hop you can define a virtual appliance. In this case we can use ASA or a next generation firewall as our next hop. I can also have virtual network gateway as my next hop if I'm using native VPN solution and I want to route traffic through that virtual gateway. I can use that as well. If I want my network traffic to stay local, I can use VNet as my next hop. If I want to send traffic to internet directly, I can use internet as my next hop. If I want to black hole traffic, I will use none. Best part of this solution is you have API integration. You can modify routes using API calls, and that is what I will show you in the upcoming slide. We use this functionality when we deploy ASAv. Load balancers, internal load balancer and external load balancer. Then there is something known as I already talked about internal and external load balancers. So external load balancer will have external IP address and can be accessed from outside. Internal load balancer is only internal. Basic load balancer is for a small setup. It does load balancing based on 5-tuple hash, whereas if you compare it with standard load balancer, it can load balance traffic coming from different VPCs as well. So if you look at the standard load balancer, it is for the bigger setup where you have more number of backend devices, and if you want to have HA port functionality. HA port functionality is something that can be enabled on the standard internal load balancer, where you can enable port forwarding or load balancing of entire TCP and UDP protocol, whereas on the basic load balancer, each time you want to load balance any traffic, you have to write your load balancing rule. So I'll not go deep into this here, rather I'll wait for the load balancer sandwich design. I'll talk about that in detail on that particular slide. Now let's begin with our use cases. First one is the ASAv. In the cloud, we don't have layer 2 visibility, so we cannot really use native HA design of sending a GARP when there is a failure, because we don't have information about layer 2 information. So in release 981.200 in August 2017, we came out with this particular model where when you go to marketplace, you will find a listing which will have ASAv. It will deploy two ASAVs with built-in HA agent. We leverage native route table and external load balancer for this particular design. Now let's talk about why HA agent is added to our ASA module. Now this ASA agent is responsible for keeping track of the backup device, and it is going to check which device is active, which device is backup, and HA agent on the primary or the active device is also responsible for sending reply to probes coming from the load balancer, because load balancer is going to look at the active ASA and get response. We just want to maintain one route, so that is why the active agent on the active active ASA is going to send reply. The important activity of HA agent is to program routes when there is a failure. So if there is a failure, HA agent is going to talk to the route table in a secured manner, because there is a proper authentication mechanism that happens between the HA and the route table. You will have to create your authentication key, app key, enable your app or app ID as the authenticator on the route table. So it is pretty secured. So if anything happens to ASA1, ASA2 becomes active, and HA agent on the ASA2 is going to send a REST API call and switch a route in the route table to itself. And it will also start responding to load balancer or probes coming from load balancer. All the front-end IPs will be on the front-end load balancer, so users will always hit public IP address from outside. And another important thing which I've already told you, but you need to make sure that the that is by design, that all the request from the load balancer is answered only by active ASA. I'm talking about probes. It is an integrated solution. You don't have to write any external script, or no external agent is required. You can enable multiple subscriptions as well. Really powerful. So if you have multiple subscriptions, you can always define your subscription ID, and you can modify routes in another subscription as well. Fast switchover, and this is a stateless switchover. This is how your HA agent is going to program multiple route tables. So in your ASA HA configuration in cloud, you can specify name of your route table, your resource group, and in the event of failure, HA agent is going to talk to multiple route tables and modify routes. These are commands specifically designed for Azure HA. So you will have to define your route table name, your resource group, and then you will specify routes. And if you look at the blue highlighted, the command highlighted in blue, you will see that I'm using subscription ID of another subscription if I'm talking to a partner, and if they are coming through ASA1, if that ASA1 dies, I can program their route so that they can come through ASA2 as well. So these are a few commands. I have created a good 1.5 hour demo video on deploying ASAv HA. You can always go back to my YouTube channel. If you have not subscribed to it, go ahead and subscribe to it, because I keep on adding a lot of videos on public cloud solutions. So you'll be getting notification whenever a new video is uploaded. So this is our partner ID that I was talking about. So subscription ID, I can give the subscription ID of my partner and create that app ID as a contributor in his route table. Then definitely I can use this for my HA. This is a route recommendation, because when you are controlling your network with ASAv HA, it is suggested to have all the routes defined in your route table. If you go back to your route table directly and add a route there is no way to sync route back from that route table to ASA. So if there is anything on ASA1, if your ASA2 is going to take over, it is going to write only those routes which are defined in the configuration. Very important step. If you want to deploy ASAv HA, make sure that you add routes in the route table rather than going directly and adding out-of-band routes. Failover, scalable design. So this is again really important to understand, because you will see a lot of requests coming in from your customers where they will like to scale their network. Now if you look at this particular example, I am leveraging external load balancer, internal load balancer standard, because I want to use HA port functionality. I don't want to write rules again and again for any traffic that I want to load balance. Rather, I would go with complete TCP and UDP stream. Now if you look at route table, in the route table I have specified next hop as virtual IP address of my internal load balancer. So I'm going to talk about traffic flow in the upcoming slide, but just to give you an example here, I've added multiple firewalls between a load balancer sandwich. I have a beautiful a 2-hour demo on how to deploy it, how to test it. You can find that link in my YouTube channel. You can always refer back to my YouTube channel for all the designs that you see in this video. So if you want to deploy this kind of model, you will see end-to-end deployment in another video. I'm going to add that video link in the description, but you can always go back to my YouTube channel and look for that thing. So now let's talk about traffic flow. Inbound traffic flow, any user hitting the external load balancer, that traffic is going to land on the firewall, because we have 5-tuple load balancing happening on the load balancer. And on the way in, I'm going to translate that traffic on the egress interface so that traffic can come back to the same device. If your traffic is external from your Azure environment to to cloud, you can send it to a to virtual IP address of your internal load balancer. Internal load balancer is going to send it to any of the firewalls available in the pool, and then you can translate traffic on the egress interface so that it can go out to the internet. Then we have east-west traffic as well. So web talking to app or app talking to web traffic will always land on the virtual IP address of the load balancer, and from there it will go to firewall, and firewall is going to receive traffic back on the same firewall, because there is state tracking happening on the internal load balancer. So on the way back, when application server will respond, it is going to send traffic back to the virtual IP address, and since for initial traffic was sent to firewall 2, subsequent packets will go back to firewall 2 itself. For east-west traffic, there is no source NAT requirement. If you're coming from data center to your cloud environment, you can add routes in your gateway subnet. You can attach a UDR there. You can add a route, point it to virtual IP address, and same way it is going to be inspected by firewall. For probes, really important to understand there are different probes available. You can probe directly connected interfaces. If you have external interface, you can probe outside interface of firewall. If you have internal load balancer, you can probe internal interface of the firewall. You can probe through the firewall as well, as shown in the first diagram, where I'm probing internal interface, but I'm translating my outbound traffic to outside interface and changing my destination IP to the management interface IP. So I'm probing something on the other side, but I'm not relying on any host in the cloud. I'm trying to probe my own device, but on the management interface. This is a reliable probe because I'm making sure that my complete firewall stack is up. My far side interface is also up there, but it requires a little bit of natting and access control policies on the firewall, which is an additional task. If you look at the third kind of probing, which is done by most of our customers, and it will not require additional. When I say additional configuration, I'm referring to what you already have on the device. For example, if you have web server 1 and web server 2, you will definitely create a translation on the firewall and allow access control policies. Now, using same configuration, you can enable probes on the same application ports as well. Now, for web server 1, I'm using probe 1, which is using my traffic port, which can be port 80, 443, or anything that application uses. So it is always suggested to go with traffic probes, because it does not require any kind of additional access control policy, routes, or netting. It will use your existing NAT statement and your access control policies. Now, there is a separation of duty as well. With some customers, we have seen that their InfoSec policy requires a separate firewall for east-west traffic inspection and separate firewall for internet connection. So in this setup, we have multiple firewalls pointing to virtual IP1, which is on the load balancer, and then on the same load balancer I have virtual IP2 as well, that points to a separate set of firewall, and that separate set, firewall 3 or firewall 4, is going to be used only for east-west traffic. Now, if you look at the UDRs here, you can see for internet I'm using virtual IP1 as my next hop, and for east-west I'm going to use virtual IP2 as my next hop. So let's talk about traffic flow. If I have any user from internet, that traffic will come to firewall, external load balancer. From there it's going to come to a firewall, and if there is another server from inside talking to outside, that traffic can land up on virtual IP1, because they're based on the UDR, it is going to be talking to virtual IP1. And in the virtual IP1, backend pool is firewall 1 and 2, so that is going to be using that particular firewall pair. If traffic is east-west, I can simply go to virtual IP2. It is the same load balancer, but two separate virtual IP addresses with separate backend devices. So this is how you can control your traffic. Another flow is from your data center to cloud, or from cloud to data center. That can also happen through virtual IP address too. Now let's talk about another use case. We get a lot of customers asking for multiple IPs on device. So if you look at this particular example, we have three web servers and a firewall deployed at the edge. On the firewall, initially I will have only one IP address, but I can assign additional IP addresses and then map those additional IP addresses to different public addresses as well. So in order to do that, what I need to do is I need to go back to my Azure portal, and in Azure portal I need to find my firewall VM. Once I go to firewall, I need to find my external NIC. And the moment I go to my external NIC, I need to go to IP configuration, and on this page I'm going to add additional IP addresses. Like in this case, you can see I have IP4, .4.5.6, and these IPs are mapped to the public addresses as well. So you can definitely add multiple addresses. Once you have this configuration on your Azure portal, you can definitely go back to your firewall and enable NATing for that. So unless you have this information available there on the device, you will never get any traffic on the firewall, even if you add a NAT statement there, because there is no concept of proxy ARP in the cloud. So now let's talk about ARM templates. If you want to deploy firewalls in an automated fashion, we have created a few ARM templates for you. You can go back to our GitHub account. You can go back to our GitHub link. There are videos available for deploying these devices in an automated fashion using ARM templates. Why these ARM templates are required? If you want to group your templates with multiple resources, and if you want to deploy those devices using JSON template, and definitely it is less prone to human error, because once it is tested, you can reuse it. You can reuse it for different environments. For example, if you have your lab environments, pre-production environment and production environment, in your lab environment you can create your ARM templates, test it, redeploy it in the pre-production environment, test everything, and then use the same template to deploy everything in the production environment as well. You can publish your ARM templates. You can publish it with your partners, your customers. You need to have their subscription ID. You can publish it, or you can download it in a text format and share it as well. AWS use cases are similar. So you can deploy firewalls at the edge in the routed form. You can manage it using Firepower Management Center, orchestrate configuration using APIs, those kind of things. Then you have passive mode deployment as well. For passive mode deployment, you need to make sure that your MTU is set to 1600. You have IP address on the interface of your firewall, which is a passive interface, and you need to ensure that you have ER span coming from CSR. So if you just need visibility rather than inline blocking of the traffic, you can always deploy your device in passive mode. Our ASA can be deployed in routed mode. Transparent mode is not available. And if you look at the route table, in the route table you cannot really add more specific route, because when you create your virtual private cloud, a local route is installed, and you cannot really overwrite that route table with a less prefix or more prefix route, because that is not allowed in AWS today. So you will have to have a system route on the workload, which will point to IP address of your firewall. AMP integration, so you can enable AMP license, next generation IPS and AMP license on your device. Using this particular subscription, you can always intercept your traffic, and if any of your front-end workload is compromised, and if that workload is trying to send any kind of malware to your database server or your application server, you can always find that out, and you can block it. So what we generally do is we create a hash of this particular file. We send it to our AMP cloud for getting the verdict. So there are different things. If you want to go in detail of AMP, you can refer to our YouTube channel, look for AMP videos. But when we get verdict, we have options. If file is clean, we send it. If file is not clean, we can perform some action on it. If file is unknown, we can perform some action. You can also send your complete firewall to cloud for sandboxing. You can create policies, and based on policies, you can allow or drop traffic. This is a ASAv VTI based solution. You can have route based VPN, which is available from release 9.7.1 or higher. You can have a hub and spoke model where you can have multiple ASAs at different locations, and ASA at the hub, and you can enable east west and north south traffic inspection. You can also remove ASAs from the hub, and you can form route based VPN tunnel directly with Azure VPN gateway as well. And at the hub location, you can put ASA, and you can enable communication between multiple VPCs. If you have ASA at your data center and you want to use native VPN connection in AWS, you can do that as well. You can form site-to-site VPN tunnel using route-based VPN, and you can enable that. So there is a complete video on the YouTube channel how to do it. Kindly refer to that for detailed information. Multiple IP addresses on AWS is again similar kind of thing. You just need to go back to your AWS portal, look for the VNIC, which is your external VNIC, click on Manage IP, go to your Manage IP screen, assign new IP address there, and then you can reuse that IP address in your ASA or FTD configuration. Unless you do this step, there is no way to get traffic for that new IP address on your virtual device. CloudFormation template is similar to AMP template. You can create a JSON template, write your scripts in JSON or YAML, create your stack. In stack, you can define multiple resources. Like in this example, we have deployed a lot of things using single CloudFormation template, and then you can share it with your partners, your customers, or you can even publish it through your S3 bucket. Again, for repeated deployment, less prone to human errors, version controlling, you can update and track changes as well. Pretty powerful tool. It will let you deploy multiple resources at once, and if you are in the network environment where you have a DevOps environment or lab environment, and then you have your pre-production environment and production environment, you can test everything in your DevOps environment, test it again in the pre-production environment, and once you're satisfied, you can use the same stack to deploy everything in the production environment as well. Scalable model in Amazon Web Services, pretty simple, similar kind of design, but let me step back and talk to you about ALB, which is Application Load Balancer. It does load balancing based on cookies. Then they have Network Load Balancer, where you can have IP address as your target. So in your Network Load Balancer, you can create target groups, and in the target groups, you can specify IP address of your internal firewalls. It is supported with ASA and next generation firewall, but there is a classical load balancer as well. Problem with classical load balancer is it can forward traffic only to the primary interface of a backend VM. So it can be used with ASA, yes, because on ASA you can use your primary interface as your data interface as well. But with the next generation firewall, definitely you need a network load balancer or application load balancer where you're going to use the target IP address. So when you pick your load balancer, we would suggest you to pick either ALB or NLB. Okay. This is our scalable design where I have ALB or NLB facing our firewalls, and we have our firepower management center managing our firewalls. Traffic will land on the external load balancer. External load balancer is going to load balance traffic across availability zones as well. You can have multiple firewalls per availability zone, so that if one firewall is down, your entire availability is also reachable. So you can have multiple firewalls per availability zone. ASA is again similar kind of design, but with ASA you can also use CLB. Again, you can deploy multiple ASAs per availability zones, and you can terminate your VPN directly on the ASA, or you can use the method that I showed you earlier, where you have multiple VPN endpoints. You can follow that model as well. Hub and spoke model in AWS and Azure. I touched base on this in the earlier slide, but I'm going to give you a detailed information on what exactly it is and how exactly it will make your life easy. If you have multiple VPCs coming down to your hub VPC, you can use CSR to have that kind of connection. You can form DMVPN, or you can use your IPsec VPN tunnel there. In this example, what I'm doing is I have CSR1 and CSR2. These two devices are running in active connecting to multiple virtual private clouds, and behind CSR1 and CSR2 I have two ASAs, ASA1 and ASA2, and between these devices, CSRs and ASA, I'm using route-based VPN. So I'm using tunnel interfaces on ASA, and I'm using BGP to decide which ASA to route traffic to. So if my ASA1 is reachable, I'm going to use that ASA as my exit point, and in case if ASA1 is not reachable, I'll fall back to ASA2 for my exit point. You can deploy a next generation firewall in the same manner in the cloud as well. You can have FTD at the edge, bring everything down to the FTD, and then you can put it at the edge for north-south traffic inspection. In Azure, load balancer sandwich model is available. Using your routes in the gateway subnet, you can control that traffic, and in your UDRs you can also add virtual IP address as your next hop. In this example, your outbound and inbound both traffics are scalable. Whenever you need additional firewall, you need to just spin up a new device, add it to the load balancer, external and internal, and you should be good to go. Licensing is really important to understand. For next generation firewall, by default when you purchase it, you have base license, and which will let you use it for firewalling, application visibility and control. You also have term-based licenses available for threat, URL and AMP. On AWS we have bring your own license and pay as you go. For Azure we have bring your own license. On ASA we have license for throughput and firewalling, and then we also have license for AnyConnect VPN. Based on that, you can go ahead and purchase your license accordingly. ASA is again available in AWS with bring your own license model or pay as you go, and in Azure it's bring your own license only. In addition to this, customers will ask you about costing of AWS as well. You can go to AWS calculator, decide your device, pick your instance size, and based on that you can estimate your monthly billing. You can do the same on Azure calculator as well. So again, you can go back and do it, do your all costings and your network planning and designing, and look at the calculator to find out exact cost. On top of this, you will have to pay BYOL or pay as you go, depending upon your selection. In addition to this, we have a YouTube channel available where we keep on posting our videos. So if you are new to public cloud and you want to learn anything new, you can just go to the YouTube channel, or you can subscribe to this YouTube channel from where you're watching this video, and you will see that we have added videos starting from scratch, how to deploy a next generation firewall or ASA in cloud, or what is a VNet, what is a virtual private cloud, how different things are deployed. Those kind of things are really important to understand before you go ahead and deploy a security solution in cloud. So I would suggest you to go to this YouTube channel and have a look at it and subscribe. Click on the notification icon, because whenever we upload a video, we want you to get notified, because we are in the process of adding a lot of new videos as well. With this, I have reached at the end of the video and the presentation. I hope you have enjoyed this video, and thank you for watching. Please come back to this YouTube channel and subscribe to it. Thanks again. Have a good day.